Good morning, everyone. This is the session Q&A session 3 from the playlist of rotational motion. The topic is center of mass, and the question for this session is written on this board. This question has been taken from the NCRT book, and this session is in continuation of the session number 2, in which we have studied about the center of mass. So the question here is, find the center of mass of a uniform L-shaped lamina as shown in this figure. So this is the lamina in terms of x and y coordinates. The mass of the lamina is 3 kg, and so what I have done is I have already drawn this figure on this x and y frame. So this is the origin, this is the x-axis, and this is the y-axis, and this is the lamina. This is the lamina, like this, and I have divided this lamina into 3 equal parts, A, B and C. So the length of this portion, or you can say this part of this lamina, is 1 meter, and this is also 1 meter, this is also 1 meter. The length of the lamina C is also 1 meter, and its width is also 1 meter. Now this is 1 meter, and the length and width of this lamina, that is B, the length and width of this portion of lamina, that is which I have indicated as B, is also 1 meter. Its length is 1 meter and its width is also 1 meter. So now for a uniformly shaped bodies or objects, the center of mass lies at its center. So for these three parts of this lamina, the center of mass of this part, that is A, will be lying at this center, that is denoted as CA. The center of mass of this portion of lamina will be lying at its center, let us denote it as CB, and the center of mass of this portion of lamina will be lying at this center, which I am denoting as CC. Now this center will be at equal distance from this side of this this portion of lamina, and it will be at equal distance from the other two sides also. So the distance of this center of each portion from any one of the sides will be equal to 0.5 meter. Now we have to find the center of mass of this L-shaped lamina. So what I have done, the first thing is that I have just divided this uniformly shaped lamina in 3 equal parts, or you can three parts which has got the same dimensions. So the as per the formula, the center of mass along the x-axis will be given as we will be first of all considering this this portion. So now the mass of this lamina is 3 kg, and since it is a uniformly shaped lamina, so the mass of the portion A will be equal to the mass of the portion B, mass of B, and this will be equal to mass of C, and this is equal to 1 kg. Okay. So the mass of this portion A, B and C will be 1 kg each, and so let us first of all find the center of mass of this lamina along the x-axis. So this will be equal to what? Consider this portion A, the mass of this is 1 kg, 1, and along the x-axis the distance of this center point is how much? It is 0.5. Okay, now consider this portion. this portion, that is the mass of this is also 1, and the distance of this center point along the x-axis is equal to 0.5 meter, plus the mass of this section C is 1 kg, and the distance of this center along the x-axis is equal to 1.5 meter, divided by the total mass, which is equal to 1 plus 1 plus 1, which is equal to 3. So this is equal to 0.5 plus 0.5 plus 1.5 divided by 3. So this is equal to 1.5 plus 5, 2, and this is 2.5 by 3. And this can also be written as 5 by 6 meter, because these distances means the length of the total length of this lamina is 2 meter, and along this x-axis, and the this dimension, or you can say the length of this lamina along the y-axis is also 2 meter. So all the dimensions are in meter. So therefore, here the center of mass of this uniformly shaped lamina along the x-axis will be equal to 5 by 6 meter. Now we will be calculating the value of the center of mass along the y-axis. So let us consider this shape. So this is the mass of it is 1. Now the distance of this center along the y-axis, this is equal to how much? 1.5 meter, plus consider this part of lamina. Now this center is at a distance of 0.5 along the y-axis, plus consider this one, this part of this lamina. So the center is lying at a distance of 0.5 meter along the y-axis, and this will be equal to divided by 3, that is the total mass. So the center of mass along the y-axis will be equal to 1.5 plus 0.5 plus 0.5 divided by 3. So this is equal to again 2.5 divided by 3. So this is equal to 5 by 6 meter. So if I want to draw the position of the center of mass of this lamina, this will be given by x is equal to 5 by 6 meter. So 5 by 6 meter is approximately how much? 0.84820. It is approximately equal to 8.83 meters. So this is 1 meter. So 0.83 will be somewhere, let us say approximately this. Similarly, the this center of mass along the y-axis is lying at a distance of 5 by 6 meter, which is equal to 0.8 meter along the y-axis. So along the y-axis means this something here. So this is, I am just taking it, this is a rough estimate. I am just drawing the center of mass. Maybe this is the point. Now this point is approximately equal to 0.83 meter, and this point is also equal to, approximately it will be equal to 0.83 meter. So this is the point. This is the point of, you can say this is the center of mass of this uniformly shaped lamina. This is this one. Because the center of mass here the center of mass of this lamina is 5 by 6 meter and 5 by 6 meter. So this is this point, which is I'm just this point. So this point is the center of mass of this uniformly shaped lamina. This one. So this is how we calculate the center of mass of any uniformly shaped body. And I hope you have understood the solution of this question. And in the next topic, I will be discussing about the motion of the center of mass. And so till then, have a nice day. Bye.